My name is Azaz Mir and I am a data scientist at Royal Cyber. The agenda for today's video is first of all, we'll have an introduction about vector databases, then we'll discuss why vector databases are so important in this era, then we'll move to some examples of different types of vector databases, and finally, we'll talk about some applications of vector databases. Let's start off with an example. Let's say we have a collection of fruits and we want to store it in a database. As our first case, we choose traditional database, either a relational or a non-relational database for storing our collection of fruits. We store an apple, an orange, and a banana in the database with some of their features. Our goal is to find and retrieve a fruit which has the same level of sweetness as an apple. Here we can see that all three of those fruits are sweet, but not all of them contain the same level of sweetness as an apple, and traditional database is not able to differentiate between them. Therefore, it marks all of them as sweet. So the traditional database gives us an orange and an apple. Both of them have different levels of sweetness than an apple. Therefore, it is not the result we desired. Now let's use vector database for storing the collection of fruits. The vector database stores different fruits with their features, and it converts those features into numbers so that it can compare and give us the results based upon the similarities of those numbers. Here we can see that although all three of these fruits did have some sweetness in them, but only an apple and a pear have similar level of sweetness. Therefore, it will cluster them together. Finally, the vector database gives us pear, which is quite similar to an apple, than an orange or a banana, based upon their level of sweetness. So in the background, when we give an input to a vector database, in this case an image of a shoe, it goes through an AI model or an embedding model which converts this image into vectors or embeddings, which are nothing but an array of numbers which represents features or attributes of that image. Those vectors are then stored in the vector database in the cluster of shoes. Later, we can use that data to do similarity searches and retrieve similar looking shoes or objects. We can find latest trends with it, create recommendation systems, or do classifications on it. Let's say we have an image of a cat and we want to retrieve similar looking images of cats with similar features as this one. Using an embedding model, we create vectors of that image. These are nothing but features of the cat, such as its color, age, etc., and store it in a vector database which contains abundant images of cats to retrieve only those images of cats which are similar to the image of the cat we gave as our input. Vector database stores data in the form of clusters or groups. Here we can see all the carnivore animals are grouped together based on their similarity of features, and all the fruits are clustered together based on their feature similarity. This is how a vector database is able to retrieve similar looking objects, and it can be any document, object, or even text. This is how a vector database is able to understand the context or meaning of sentences. Now let's take a look at some applications of vector databases and some companies which use vector databases for that particular purpose. Using vector databases, we can do semantic search, which means we can find any text based on its meaning or context. Documents like PDF are called unstructured documents, and traditional databases are not able to search through unstructured documents. But a vector database is built for that purpose. For recommendation systems, Spotify prominently uses vector databases to recommend songs of your liking. Next, vector databases are used for classifications and clustering, for anomaly or error detection, and for building applications which include large language models or LLMs. Here we can see that we have two types of vector databases, open source and closed source. And among those, there are some vector databases which supports vector search and some do not. Now let's analyze how different is a vector database from a traditional database. A traditional database stores data in the form of tables or collections, but a vector database is able to store in the form of vectors. Let's look at some more differences. A traditional database storage cost increases as the size of the data increases. And for vector database, storage cost depends upon the dimensions of the data, which are features or attributes of that data. The performance of traditional database degrades as the size increases, but a vector database is designed to handle large-scale data. It can get costly to maintain traditional database, but due to the distributed nature of vector databases, that overhead is mitigated. If you want to know more about vector databases, you can follow us on LinkedIn or email us at info@royalcyber.com.